Hybridization is a mix of two or more things. But before we get to hybridization, I have to introduce a couple new vocabulary words to you. The first is the word sigma bond. Ha 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 ha. Sigma bond. Hey, listen. Sigma bonds are not hard. It's just a new vocabulary word that we need to start applying to things we already know. Okay? A sigma bond is another word for the first bond that is made.
Ah, shit.
Thanks, Reagan. The first bond that is made. For example, if I look at methane, CH4, it's a carbon surrounded by 4 hydrogens. We've seen that a million times. We've used it. We've looked at it. It's great. Every single one of those bonds is a single bond, right? How many bonds are in a single bond? 1. Is that the first bond that's made? Yeah. Is that a sigma bond? Yes. Every single bond is also a sigma bond. Every single bond is also a sigma bond, but there's more. And these come from our doubles and our triple bonds. If I have this guy, nitrogen, he's bonded by a triple bond. This is how sigma bonds work. Sigma bonds are only the first bond that's made. So here, how many bonds are there? There's 3, but only one of those came first, right? This would be the only sigma bond. Here.
Sigma bond.
Then we introduce the second type. These are called pi bonds. Pi bonds are formed out of leftover p orbitals. That should not be a new concept to y'all. P orbitals are back from electron configuration and orbital notation.
Triple electron.
In a p orbital, or not p orbital, excuse me, in a double or triple bond, the p's, the pi bonds, well, that's just everything else. It's either going to be the second or the second and the third. So in this case, we have 2 pi bonds. Are we tracking?
I'm sure.
So if I made a molecule that looked like this, let's do
CH4. Hybridization.
Let's say I had a molecule that looked like this. How many sigma bonds do you see here?
1.
Say it in your head.
Oh, sorry.
How many sigma bonds are there in this whole guy? I count 5.
5.
I count 5. Watch. 1, 2, 3, 4. Because
So
all
first-
single bonds are
first
always sigma bonds. And then the first bond and a triple bond. Does everybody see where I got 5? How many pi bonds do we have then?
2.
2. 1, 2.
What about double bonds? Is it just
A double bond would be 1 pi bond and 1 sigma bond.
Okay, great.
Are we good so far?
Yes.
That's the easy part. Has everybody written down the stuff at the bottom of this slide? Because I'm going to refer back to it here in a little bit.
See.
Okay. So it's my understanding that we do not know how to draw Lewis structures.
Nope.
First period said that y'all have not learned how to draw Lewis structures yet.
Can we see it?
Okay. Huh? Okay. Hey, I am going to introduce something to y'all. I'm going to teach you the way that we do orbital notation. Orbital notation, y'all should have done before, but how it works. We're going to start with carbon. We're going to start with the orbital notation of carbon. Shut up, Adia.
Do you think Miss Briere comes and like watches these videos? Do you think she does?
All right, here, look, carbon. How many electrons does carbon have, according to your periodic table?
4. 5. 4.
How many
minus
total electrons? AKA, what's its atomic number?
6.
6.
100.
So carbon should have 6 total electrons. In orbital notation, what do we always start with? Do y'all remember that? It starts in the top left. What's the top left?
The S1.
1s. We always start with 1s.
Oh, 1S1.
Just 1s. Hey, how many orbitals can go in an s?
2.
1.
Oh.
All s's get 1 orbital. How many electrons can go in 1 orbital?
2.
This is how we do this. 1, 2.
Oh yeah, she showed us that.
Oh, I thought
Yeah,
this
we
one was
kinda
way
did this.
so more confusing.
Did they say we didn't do this?
Yeah.
She
We did
showed us
this.
that.
I have
said
this
that
in
y'all
my
did
notes.
this.
We
I was told that y'all did not do this.
Yeah, well, we shouldn't listen to anything that period 1 says.
So,
because there's a bunch of
Hey, what's after 1s?
2S.
2s. How many orbitals go in 2s?
Yeah, for real. They're just
2.
Huh?
1,
1.
Oh, sorry.
How many electrons can go in that one orbital?
2.
Wait,
One,
so that's
two.
that's the orbital. The line is the orbital.
Yes.
Oh, okay.
Hey, what goes after 2s?
1P.
2p.
Oh, 2P.
That
I have it right here.
2p. How many orbitals can go in 2p? 3.
3.
1, 2,
6
3.
electrons.
Like P3. Have y'all ever had a P3? You can buy those at Walmart.
Yeah. We have.
Hey, but how many electrons do I need to put in P right now?
So we have all the way to 7.
2.
I only need 2 more. I needed a total of 6. I've got 4. I need 2 more.
You don't double them up.
We have to go 1 and 1 according to Hund's rule.
Yes. Hunt's rule.
There's my orbital notation for
This is
carbon.
easy.
I know.
Reagan,
Hey, here's how this way works. I'm going to teach y'all some principles. The first is off-bow's principle. Off-bow just says we always start at 1s and work our way to the right and down, like reading a book.
Yes, you.
Pauli's exclusion principle. They have to be opposite spins.
Yeah, bro, we know.
You see how one's pointing up, one's pointing down.
Like the
And finally, Hund's rule. 1 in each line before you start doubling up.
Yes.
Cool?
Yeah.
Okay,
You have to.
there's my little recap.
Because everyone has to get firsts before you can go.
Correct.
Back and get seconds.
Hund's rule.
Thanksgiving.
Not really, bro. Except I get
That's
seconds
not
whenever
true.
I
I
want.
get seconds. I don't. Get
So now I need to figure out how to draw a Lewis structure from this. The way that we draw Lewis structures from our notation, we first need to find how many valence electrons we have. The way that we tell valence electrons, I'm going to look for the electrons in the highest energy level. Do you remember what determines energy level? From this guy.
What?
Double or not.
No. It's the big number. We're going to look for the biggest big number.
Oh, you mean levels? Oh, yeah.
So what's the highest big number here?
2.
2. So I'm going to look at my 2 2s, which means I do not care about the 1 at all. Don't care about it. When I look at my 2s, how many electrons are in my 2s? How many electrons are in my 2s?
2.
I see 4. 1, 2, 3, 4.
2 in each.
Everybody good so far?
Yes.
This is how a Lewis structure looks. You start with the symbol. The symbol for carbon is a C. We said there's 4 electrons, right?
Yeah.
A Lewis structure. You have 4 sides.
Lewis.
Lewis structure.
Oh, so that's
Like,
where
how do we
valence
spell it?
electrons?
Lewis.
I see.
So look, you can have, there's 4 different sides. There's the top, the right, the bottom, and the left. You can have up to 2 electrons on each side. But, just like Hund's rule, there has to be 1 on each side before you start doubling up. So here we have 4 electrons. So I'm going to go 1, 2, 3, 4. That's the Lewis structure for carbon.
That's it.
Oh, That's so easy.
Is everybody tracking so far?
Why did they act like it was the end of the world?
This is like, no, this is stuff that like
Because we
first
should
period
have
said that
learned-
you did not learn last semester, but you need to know.
We
don't
didn't
care
learn
about
the
the
Lewis
line.
structure. We learned how to do
We
it.
learned this half, but she briefly taught it.
Okay. So we know this, and now we know this. Now it's time to move on to new stuff.
Oh, wonderful.
I think period 1 just lies to you.
I think.
We need to figure out these 4 things for each of these. We're going to start with the Lewis structure. Hannah, put your phone down.
Sorry. It was important.
You can yell at me like that, but don't yell at my Hannah like that.
I would yell at anybody
She's the
like
sweetest
that.
little angel. Don't yell at her.
Uh-huh.
Reagan said cap. Okay, look.
Hannah's hiding.
The first thing we're going to do is look at lone pairs. Lone pairs is not a new concept to y'all. We love lone pairs. We use lone pairs all the time in Vesper, which we just finished. Here's lone pairs. Look, what does a lone pair look like? It's 2 dots next to each other, right?
Yeah.
Unbonded electrons. Look here, do you see any lone pairs?
No.
No. I see 1 electron, 1 electron, 1 electron, 1 electron. None of them are doubled up. So this guy has 0 lone pairs. The next thing I want to look at is electron density. You've looked at electron density before. You didn't know you were looking at it, but it was. If you look at your Vesper handout that I gave you for Vesper with all the shapes, that column on the left, you're looking for electron density around the central atom. Things touching the central atom. Here, electron density is just how many sides have something on it. In this case, how many sides have something on it?
4.
4. 1, 2, 3, 4. So we have 4 as our electron density.
4 what?
Oh, shoot.
Electron density,
Pay
ED.
attention to that.
Binding regions. These can also be called bonding regions. I don't care which one you use. A binding region or a bonding region is anywhere that we can form a bond. In other words, we need a side that can take in another electron to form a bond. This is like what we did at the very, very beginning of nomenclature when I was drawing all the pictures and we had to say, okay, well, if I had this aluminum, I can make this oxygen happy, but now I need another aluminum to make another, like you remember that kind of briefly? Same thing here. So how many spots can I form a bond? How many spots can take in another electron, essentially?
4.
4. I can put one here, put one there, and put one there. Everybody cool so far?
Don't change the size.
And finally, we have orbital notation, which we already drew. We're good to go there.
So I don't have to write anything.
Huh? No, I'm just reading the slide. So orbital notation, that's this. Hey, but now we're going to look at these same 3 things, but over here, for this guy. What were you going to say, Vivian?
So, orbital notations.
This is orbital notation. This whole thing.
So, how much?
Huh?
How much?
No, you don't have to write anything for that. So we're gonna look for these same 3 things, but over here. Remember, we're just looking at the valence stuff, only the outer stuff. So again, we don't care about 1s at all. So looking at the 2s, these 2 guys, how many lone pairs do you see? Where there's 2 electrons right next to each other.
No.
1, I see 1 right here.
Oh.
Does everybody agree with me?
Oh,
Yes.
Regions of electron density. Anywhere where there's at least 1 electron.
Why is there 2 lines?
Here? Because I just felt different. It's just an arrow. Will it make you feel better if I write 1 line?
What color are they?
Like you think I didn't do that assignment? I freaking did it, bro.
Okay. Okay, electron density. So looking here, there's 4 total orbitals, just like we had 4 total sides. Well, how many of my orbitals have at least 1 electron? 3. And finally, we have bonding regions, or binding regions. How many spots, how many orbitals can we use to form a new bond?
3.
2. 2.
Well, I didn't know.
That guy's empty. There's nothing there for me to form a bond with. But these 2 guys, those guys are ready to accept a new electron and either begin donating or begin sharing. So we have 2 binding regions.
So binding just means bond?
Yeah.
Okay, great. So why is it called binding instead of bonding?
I literally have said this entire time you can use binding regions or bonding regions. It doesn't matter. I think I've said that 4 times.
Whoops.
Wait, so these look.
Goodness forbid, y'all has
1, 3, and 2 are from that.
1, 3, and 2 are this guy. 0, 4, and 4 is that guy. Hey, but look!
I'm writing the orange and I'm writing orange.
Brush stroke.
Reagan, look! Hey, what do you notice about these 2 things?
They're different.
They're different. But aren't they both for carbon?
Yeah.
Why are they different? It's because orbital notation lies to you.
Oh.
Orbital notation lies to you until we fix it using hybridization. Welcome to hybridization. This is how this works. Please pay attention. Do not write anything yet. Just follow along with what I'm writing and pay attention. The way that we fix it, we're going to take the amount of orbitals in our valence region and combine them. You said you forgot to do your math homework?
No, I thought I did it, but I literally did it during study hall last period.
So look, we have how many valence orbitals? How many orbitals do we have in total as part of our valence orbitals? I see 1 from 2s. I see 3 from 2p. So how many is that in total? 4.
4.
1, 2, 3, 4.
We used to do this all the time. bro.
Teacher.
Hey, look. How many came from s?
1.
How many came from p?
3.
3.
How many electrons did we have in total there?
4.
We had 4. Now I'm going to move those in here.
So you
Hund's rule says we have to put 1 in each before we double up. 1, 2, 3, 4.
I'm
So
smelling
what
what
is
you're
it?
cooking.
Now let's look at the same thing we've been doing. How many lone pairs are there?
0.
0. Isn't that what we have here? How many regions of electron density do we have?
Oh, dude,
Oh.
4.
4. Does it match up here?
Dude.
How many binding regions do we have?
4.
Oh my god.
This is how we named this, because this is not just enough. We need to name it. How many S's did we have in total here?
1. I'm confused.
So S, there's an invisible 1 right there. How many P's did we take?
3.
This is called sp3 hybridization.
Why did I write that?
Huh?
The 1 through 2, LP, ED, BR.
That goes with this.
All of it?
Yeah.
This is, and that goes with that.
This stuff goes with here. This stuff goes with there. It's the same as this for that.
This, that, and the other. I don't know what you just said.
I could have rewritten all of this in blue for this guy. I didn't have to, because the whole point of this is what this really looks like.
Yeah.
This is a liar. This is what it really looks like. This should match up to your Lewis structure.
Okay.
Oh.
Once you hybridize it, these 3 things should look like your Lewis structure.
Gotcha.
I'm finally getting it right.
Can I write that down now?
Yeah, now you can write it. Sorry.
Okay.
I'm not angry anymore.
I'm glad.
I just thought of what I'm gonna do.
I almost had
Okay. You want to talk about what you're going to do?
I'm gonna make a group chat of all the girls and be like, the plan is to wear dresses, and if you don't want to be a part of the team, then that's your choice.
Be a captain. There you go, Clay.
Heck
I
yeah,
am the
fuck
captain.
it.
That's what I'm talking about.
Show your
Are you gonna
captain.
wear your
Ability.
So you're
Captain.
I mean, it's not, I can't.
like
What do you
it's
say,
not-
Gage?
I got them a large. Yeah, I'm gonna wear mine inside. I'm gonna wear jeans because I'm not gonna be there all day.
My jeans are pretty cool.
Yeah,
'Cause it's not valence.
Homies on the Chromies is live now.
Huh? My Chromies is live right now.
Yeah.
Bro is there locked in.
Not in these.
You ever give my money back?
My mom keeps sending
Your
me
what?
grades.
My silly green.
No.
Imagine getting it taken.
I'm keeping it all day.
Bruh.
It's mine all day.
I thought that's what my teacher is peeing right now.
Does she do more?
I
Airplane
laid down my
mode.
son.
What?
Why'd you put
Don't we look like people that
Now
have
it's not
missing
connected to your watch.
assignments, bro?
Yeah, do we look like people who have
We
missing
did our
assignments?
assignment
Yes.
and she doesn't even know, like, her assignment
Did you get
was
more
messed
missing?
up.
All right, did everybody get this one? Are we good?
That's all it says.
Hey, I want you guys to do the exact same thing we just did, but for oxygen. Do it for oxygen. You've got 5 minutes to go. Hurry up.
Just the Lewis structure?
All of this, except for the hybridization part. You don't have to do the hybridization part.
But that's the main part.
I know. We're gonna do that together. Just get to the Lewis structure with your LPs, EDs, and BRs.
O equals 8 electrons.
It's just O, bro.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Somebody's missing.
Lucy.
Oh yeah, I'm literally on her desk right now.
Where is she?
I don't know. She
She's
won't
sick.
answer. She's not. I thought it was.
According to Infinite Campus, she's sick.
Actually,
Well, she better get unsick real soon.
yeah, she got sectional speaking and show choir.
Yeah, we need her for show choir. She's
When
in
does your show choir
rapper.
come?
This Saturday.
No, like at what time?
Like 11 and
You missed some stuff. Basically, we just said, here's your Lewis structure for oxygen with 2 lone pairs, 4 electron densities, and 2 bonding regions. Here's your orbital notation for oxygen with 2 lone pairs, 4 electron densities, and 2 bonding regions. And then here's your hybridization,
Okay.
SP3.
You just said something really smart. I was gonna write it down, but I forget what you said.
They don't always, the hybridizations are not unique to each element. Elements share Elements share their hybridization all the time. It's based off of sigma bonds and lone pairs. Now, most free elements are really easy. It's either SP, SP2, or SP3. Once we get to bonding, which is what we're going to do next, this is when things get fun.
Fun. Is it fun?
I think it's fun.
Of course it is.
Hey,
Chemistry is fun.
all roads lead to Rome.
Frick.
Yeah, they
All roads do
did.
lead to
They
Rome.
did.
Can you give me my pen?
What does that mean?
They did.
It means that time is running out.
Thank you.
And yeah, our Rome
When do
already
we leave?
happened.
Hey, who's y'all's
My
English
Rome
teacher?
is gone.
Mine.
I don't have English.
I don't have English.
I don't have
Yeah,
English.
mine is restored. My Rome is back.
I can speak.
Oh, she has a new one. I do not have
And
a
he's
new one.
Who
literally
teaches
amazing.
speech?
I have
Mr.
scales.
Waddle.
You have to get
There's like
to
3 different speech teachers.
Yeah, there's
What the frick?
I have Mr. Waddle.
I have
There's
scales.
like Paris or something, not Alaska.
Scales. Waddle,
Okay,
Smith.
pay attention. Do not write what I write yet.
I don't know.
Oh, Nat.
7:45.
When do we leave? Really? Like, I got...
In 7 minutes.
What?
Because yeah,
We're
I
like
need to
6
make
and a
sure
half
we have.
minutes.
I have time to write this.
We don't write this?
We
Not
do.
yet.
Not yet.
Oh, not yet. But is yet gonna be in 7
Okay.
minutes?
You shut up, Reagan.
Country road.
Hey, we need to be a lot nicer to our classmates and our teammates.
All right, ladies and gentlemen. Hey, I want to think back to the introduction slide. I want to look at sigma bonds and sigma bonds, double bonds, and lone pairs, pi bonds, all the things. First, I want to look at how many sigma bonds do you think there are? Say it in your head. Don't say it out loud. Count in your head. This whole thing, how many sigma bonds do you think there are? I told you, sigma bonds are all sigma bonds plus the first bond in a double or triple bond. How many do you get here?
9.
I get 9. Does everybody agree? Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9.
Heck yeah.
Pi bonds. How many pi bonds do you see?
1.
I see 1 right there. How many lone pairs are there?
1.
0.
0. Is it double
No,
bond,
there's
lone pair?
4. 2. Sorry,
Two.
2.
There should be 2 lone pairs. On your homework, you need to be able to look at a molecule and you need to figure out where do I need lone pairs.
Boy.
Here, I need lone pairs right here and right here.
That's a double
Why?
dab.
Why do you need lone pairs?
Because everything needs to have 8.
But why are they both on oxygen?
Yeah.
Because everything needs to have 8. Without those lone pairs, how many does oxygen have? 4. How many more does it need?
Why does it have 4?
1, 2, 3, 4.
Now it has 8.
Why the heck does it have 4?
Because the lines are
Because every bond is 2.
It's a girl.
Sorry.
All right. That's going to be a majority of their hybridization part on your test. Or your quiz, sorry. Hey, let's look at the hybridization now. When it comes to hybridization of a molecule, listen, because this will trip you up. You cannot tell me the entire hybridization of this whole thing. That doesn't exist. I have to tell you what atom to find the hybridization of. So here, I want to find the hybridization of this carbon. You guys can start writing now. Hey, everything that we just did with orbital notation is great.
So is it still the carbon 6?
Listen, everything you did with orbital notation is great. I'm going to teach you the shortcut where you don't need to do orbital notation anymore. There's a shortcut.
So I'm not writing this.
You need to write this molecule down, Reagan.
Oh.
You just don't need to find. You don't need to rewrite the orbital notation for carbon because you
I
don't need
hate
it.
chemistry. No, I don't. Just kidding. That's a joke. I love chemistry. So I'm taking chem too because I love it so much.
I'm taking Kim too because I was bad at bio.
Yeah, for real. Freaking bugs at bio. I was gonna say that. I was gonna say that.
Don't tell the biology people this, but biology is so boring.
You're crazy.
It really is.
It really is.
And you think chemistry's cool?
Chemistry
I
is
like
so
the math
fun.
part of chemistry.
I would.
So look, here. This is how.
Hashtag
Are y'all ready for my shortcut?
Yeah.
You don't need to do that.
Here's my shortcut. I told you on the introduction slide, the only things I can hybridize are sigma bonds and lone pairs. So I'm going to find how many sigma bonds the thing I'm looking at has.
3.
How many sigma bonds does this carbon have? 3. How many lone pairs? How many lone pairs are on just that carbon?
0.
0. What's 3 plus 0?
3.
That's how many orbitals I need in my diagram.
Frick, you mean orbital, bro?
So look, I need 3. Here we go. 1, 2, 3. Can everybody see that red? I don't know if they can see it on the video. I think they can.
It's okay.
There's 3 because I needed 3. The first orbital is always an S. Every single time, the first one's always an S. Everything else is a P.
What?
No, what? Say it.
No.
What? What was your question?
Shouldn't P always have 3?
Not when you're doing hybridization. Hybridization, the other rules where P is supposed to have 3. Don't think of this as like 2P. It's just 1P orbital, 2P orbital.
Okay.
Hey, I don't even care about how many electrons are in here. I really don't. All you're gonna do is smash these together. How many S's are there?
1,
How many P's?
2.
This is SP2.
That's just our
hybridized.
homework?
That's your homework and your test.
That's
or
literally
quiz.
light. It was my email. You mean quiz?
What?
Oh, I was just like.
It's literally just that part.
That.
Where you tell
Doing-
us find a.
Okay.
Yep. So I'm gonna ask you how many sigma bonds are in this molecule? How many pi bonds are in the molecule? How many lone pairs are in the molecule? What's the hybridization of this one thing? What's the hybridization of the one thing?
So is that?
Hey, can we do one? Do I have time to do one more?
No.
Okay, well I'm gonna do it anyways. I guess if you don't want to write it, you don't have to, but I want to do it. We're gonna look at PP.
Baby.
Here's PP. The hybridization of this guy. How many sigma bonds are there? 1. How many lone pairs?
0.
I see 1 lone pair. Add those together, I get 2. I need 2 orbitals. So the first one's always S, everything else is P. This is SP hybridized. I wanted to make sure I showed you SP, SP2, and SP3. No, I told you I'm keeping it all day. Yeah. Peace.